Howdy! Welcome to Aspire Mountain Academy. I am Professor Curtis, your instructor for this course in Introductory Statistics. In less than 10 minutes, this video introduces the coefficient of variation and shows how to use it. Let's get started. In the previous mini lectures, we've examined different ways to quantify variation within a data set. There's yet one more way we need to examine, and that's the coefficient of variation. Often you'll see this abbreviated CV or COV in either uppercase or lowercase letters. It basically describes the value of the standard deviation relative to the mean. Now, COV applies only to data sets with non-negative values. So that means the values for the coefficient of variation are always positive. Usually, coefficient of variation is expressed in percent form because it aids comparison. Speaking of comparison, the data sets you compare with COV need to have similar means. This should make sense when you consider that COV describes the value of the standard deviation relative to the mean. So if you don't have similar means in the data sets you're comparing, then your COV values will be based off of different neighborhoods on the number line, making comparing any comparison you use for them like comparing apples and oranges. So it's a good idea to check first that the means in your data sets you're going to be comparing with the COV are reasonably close to each other. Now, we can calculate COV for both samples and populations. The sample coefficient of variation is simply the sample standard deviation divided by the sample mean and then multiplied by 100 to convert from decimal form to percent form. The population coefficient of variation is calculated likewise, using population parameters instead of sample statistics. You'll probably never use these equations since you're likely to use StatCrunch when you need to calculate COV, but it's still good to know what the computer is doing for you. Let's look at an example to see how to work with the coefficient of variation. We're going to use COV to compare variation in the heights of elected U.S. presidents and their electoral opponents. At this point, I'd like you to pause the video, go open the POTUS file in StatCrunch, and calculate the COV for these two groups. You're going to follow the same steps as you would to calculate the mean or the standard deviation, except you select COV from the list of stats to calculate. Go give that a go, and when you get back, we'll retrace the steps that lead to the right answer and see how you did. Okay, how did you do? Well, let's find out. Once you have the POTUS file in StatCrunch, go to Stat, Summary Stats, Columns. Then in the Options window, select your columns. Notice we're selecting 2 because we want the COV for 2 groups so we can compare them. Select Coefficient of Variation from the list of stats to calculate and press Compute. You should see a Results window that looks something like this. If you don't, then go back to StatCrunch and keep trying until you do. So here's our COV values. Remember that these are percentages. So if the variation in the two groups is significantly different, then you should see a significant difference in the COV values. So what do you see here? Is there a considerable difference in variation between the two data sets? Why or why not? I'll give you a moment to respond. Well, these values here are percentages, and they differ by less than 1 percentage point, so that's not very significant in any context. Now, you may be wondering how much of a difference is enough to be significant or considerable. That's an excellent question, and I have an excellent answer to match it. Normally, the problem statement will contain the threshold value you're supposed to use as a standard for comparison. Here, no such threshold value is supplied, which sometimes happens. So in that case, you simply assume a threshold value. And the safest assumption you can make is to use what is by far and away the most commonly used threshold value, 5%. You should recall that this was the same assumption we used when talking about p-values. Using a 5% threshold to judge significance is pretty standard across the board. Our difference here is that this example is less than 1%, so that's well within the bounds of insignificant differences. But normally, you'll be told what threshold separates significant and insignificant values. And that brings us to the end of this mini lecture. I hope you found it helpful. You could find more mini lectures for this and other courses at AspireMountainAcademy.com. Thanks for watching. I'll see you in the next video.